Okay, so let's see how we choose between linear versus switching regulator. So there are few points which we need to consider when you want to decide whether we want to use linear or switching regulator to deliver power to any system. So first thing is cost. So linear regulators are cheaper compared to switching, mainly because it doesn't require inductor, and inductor are costlier compared to capacitors. Power is another thing. So in a multi power domain, linear regulators are preferred over switching regulators for low power domains, because if we, let us say 90% of the power is being catered by switching and only 10% by linear regulators. So even if your linear regulator has lower efficiency, overall impact on the efficiency will be negligible. Then switching regulators are preferred for high power application. So that is what I meant when I say 90% of the power is delivered by switching regulator. Then conversion ratio. Conversion ratio means the ratio of output to input voltage. So efficiency of linear regulator is comparable to switching regulator for higher V out over V in, because efficiency of linear regulator is nothing but V out over V in. So if your V out by V in ratio is more than 90% or 0.9, then your linear regulator will have efficiency more than 90%, and which will be as good as switching regulator, the efficiency. So we can always prefer if a dropout voltage is less or V out minus V in is smaller. Then switching regulators are preferred when V out over V in is less. So let us say from 5 volt I want to step down to 1.2 volt. Obviously your dropout voltage is much higher, and previously we saw the example that 3.8 watt will be lost in the power FET or pass transistor of linear regulator. So your efficiency will be very bad. So in that case we would always prefer switching regulator. And noise is another point to be considered. So linear regulators are quiet because they are not switching, and since linear regulators are switching, so they inject lot of noise in output as well as in VDD and ground. So any noise sensitive applications such as RF sensors and other analog circuitries, we always prefer linear regulators. So let us take few examples. So let us say I have a system. So linear versus switching regulators. So let us say my input is 3 volt. I am just taking a number, it may be any voltage, or it may not be fixed also if you are considering lithium ion battery. But for simplicity purpose I am just considering fixed 3 volt. So let us say I have a system A which requires 1.5 volt and 0.1 amp. Let me make it a bit some more space. .5 volt and 0.1 amp, which means the input supply for this system is 1.5 volt, 0.1 amp. Then I have another system let me call it system B, which requires, let us say 2.5 volt and 1 amp. So which means I have to convert this 3 volt to 1.5 volt for system A, and for system B I want to convert 3 volt to 2.5 volt. So, one example could be I can use switching regulator here. And switching regulator. This case also. So, we have two switching regulators. So, this is your case 1. And this is, let us say, 90%, efficiency is 90%. For this case also efficiency is 90%. So, overall efficiency will remain 90%. Okay. Now, let us take another case where both are linear regulator. Yeah, we can. Okay. So, this is your linear and this is also linear. We need to calculate the efficiency. So, I will delete this and this is your case 2. So, efficiency, this is 50% because we are dropping 1.5 volt this. So, efficiency is nothing but V out over V in. So, this is 50%. Efficiency in this case is 2.5 over 3, 83.33. So, let us see what is the total efficiency here. So, here we are losing how much? 150 milliwatt. So, total power is here 300 milliwatt in this branch left hand side, and the total power here is how much? 0.5 into 1. So, 500 milliwatt we are losing there. So, 500 plus 0.15 plus 0.15, so 0.3 plus 0.5 plus we are delivering 2.5 watt. So, 3.3 is P out over P in is this is 2.65 over 3.33, 80% roughly. Okay. Okay. So, now even your, if you see left hand side, basically in this case 2 left hand side, your linear regulator which is delivering 100 milliamp current or 150 milliwatt of the power is having 50% efficiency, but overall efficiency is dominated by the right hand side because that is 83.35% because we are delivering more power by that regulator. So, only 3.3% overall drop you see in the efficiency, and compared to switching regulator we see 10% drop in the efficiency, which means now let us say we take this again and we will make one more case. So, case 3, this will remain 50% and I will change this to switching regulator. So, this will become 90%. Okay. Now, let us calculate the efficiency again. So, what will be the loss in 90%? So, loss will be your, so roughly 0.27 77. So 0.277. So 2.5 plus 0.277 plus 0.3. So 3.077. 3.077 is the input power and 2.6 watt is the, sorry, not 2.6, 2.5 plus 0.15, 2.65. Yeah, correct. So 2.65 divided by 3.077, it's 86. Okay. So we lose 4% compared to when you use both switching regulator. So which means if we replace only low power supply of a low power system with linear regulator, the overall impact will not be that huge, as we have seen here. When you use both regulator, your impact is 10%. When you use this 100 milliamp supply is basically generated by linear regulator, and 2.1 amp supply is generated by your switching regulator, then impact is only 4%. So that is how we decide whether, so if we can afford to have a 4% loss in the efficiency at the gain of the basically cost here, this linear regulator are more cost effective compared to switching regulators because they do not require inductors. So then we can choose to supply 100 milliamp with linear regulator and 1 amp with this switching regulator. Okay. So there could be third case also where we can modify this circuit and improve the efficiency. So let us say, what if I take this again, not third case, it is a fourth case. So we know the efficiency of linear regulator is determined by the dropout voltage, and if we reduce the dropout voltage, the efficiency will improve. So what if I do this? Okay. So instead of supplying 3 volt directly to linear regulator, I can give the input from 2.5 volt, which is generated from the switching regulator. So what would happen? Now dropout voltage is reduced to 1 volt. So efficiency will be your 1.5 divided by 2.5, which is 60%. Okay. This is case 4 and efficiency here is, so now let us calculate this. Output power remains same, 2.65 divided by, so this current will change now, which will become 1.1 amp. Okay. So efficiency will remain same, let us say 90% we keep the efficiency. So this will become 2.5 multiplied by 1.1, 2.75, 2.75 multiplied by 0.11, it is 0.305 loss, and here we are losing 0.305 plus 0.1, 0.4, it's 3.05 roughly. So 2.65 divided by 3.05 5. So, you get pretty close to 87%. So, 1% you can gain by changing the and increasing the efficiency of your linear regulator by 10% there. So, when I say 1.1 amp, this is actually 1.1 amp is this, which is coming from the output of your regulator. Okay. So, 1 amp goes here in system B and 0.1 amp goes in the linear regulator, which is basically generating the supply for system A. Okay. So, now by improving the efficiency by 10%, overall efficiency is improved by 1%, because we know the the total power contribution of linear regulator is much less compared to switching. That is why 10% improvement in the efficiency is showing only 1% efficiency in the overall system. Okay. So, still you can the difference between both switching, which is 90% compared to one switching and one linear, can be reduced by 3%. So, the last one, the case 4 is like a best combination in terms of efficiency as well as cost actually, because if you go from system case 3 to case 4, you hardly see any difference in terms of regulators actually. Both are using one switching and one linear. So, in terms of cost there will be hardly any difference, but we are able to achieve 1% more efficiency, which is getting us closer to both switching regulator, which is giving me 90%. So, that is how we decide where to use switching and where to use linear regulator. Similarly, you can consider a case where the voltage might be different. So, let us say instead of 1.5 volt, if in this case, so let us say this output required is closer to 3 volt, let us say 2.8 volt here, then we can straightforwardly forward use drive from 3 volt directly, and because my dropout will be only 200 millivolt, then we may not bother much about that. And so, in this case, if we both use a linear regulator and this becomes 2.8 volt, then this efficiency will further improve. It may go to 82% or 83%. So, it all depends on the total power, as I mentioned earlier, and the dropout voltage. Based on these two parameters, you are going to decide where to use switching and where to use linear. Okay.